So for the final exam, part 2 review, I'm going to cover a few things from the 5th exam. Now, just because we've covered the 5th exam very recently, I'm not going to be inclined to put too many problems on the final exam from that. There was one problem in particular that I was kind of unhappy about, and that was expanding the sum. That's something that I hope that you guys can do pretty easily. This should probably be an n to match this over here. So let's fix that. Let's make that an n. So when n equals 1, put in a 1 here. 3 plus 4 times 1 is 7. When n equals 2, 4 times 2 is 8, plus 3 is 11, and so on, all the way up to 75. 75 times 4 is 300, plus 3 is 303. So that's how you could expand this sum, this series. I probably want you to find something like S sub 75. Now, on the test that you just took, this was a lot harder because I didn't tell you how many terms there were. You had to figure that out. You had to figure out that, oh, this is a geometric series. First term is 7 plus n minus 1 times d. D is the common difference. That would be a 4. So if you solve this equal to 303, then you can figure out, oh, gee, this was the 75th term, and then you can plug it in this formula. Here, that number comes from the summation. The upper limit here is 75, so you've got that, that's 75. S sub 75 would be 75 terms. Here's the first term, here's the last term. And that's all there is to it. The rest is just taking out a calculator. Let's see, that's going to be 75 over 2, so 37.5 times, call it 310. One thing to notice is that we got a nice even number. You should get an even number. None of these numbers has decimals. If you've got a number with a decimal, there's something wrong. So 11,625. The things that I want to quiz you on are things that are going to be important moving forward. So maybe just a little bit of light stuff, geometric versus arithmetic. Geometric means that there's a common ratio between, say, a sub 3 and a sub 2, gives you r, or a sub 4 and a sub 3 would also give you that same r. For arithmetic series, it's a common difference. So a sub 4 minus a sub 3 is that common difference, or a sub 5 minus a sub 4, again, is that common difference. You should know the difference between the arithmetic and geometric. Perhaps arguably more important than that is being able to expand a binomial without necessarily multiplying it all the way out, rather using Pascal's triangle. So as a reminder, in each row of Pascal's triangle, they start out with a 1, and they end with a 1. But in between, you add these 5, 4 and 6 gives me 10, 10 again, and then 5. This row should always be symmetric. And you would use that in expanding something like, say, let's do 2x minus 5y to the 4th. And yeah, that'll work. So we'll start out with 2x raised to the 4th plus, and then leave some space here for a coefficient. 2x times minus 5y. 2x is going to be cubed. 5y is going to be the first power. Leave some space. 2x to the second power. Negative 5y to the second power. Notice that at this point, these exponents always add up to 4. There's a 4, 3 and 1 is a 4, 2 and 2 is a 4, etc. Let's keep going. 2x minus 5y. This one's to the third, that one's to the first, and then finally, minus 5y to the 4th. So we need to expand these now. But before I do that, I need to plug in the coefficients from Pascal's triangle. That'd be a 1, 4, 6, 4, and a 1. I think a lot of the problem in expanding these things is people want to do a little bit too much. 2 to the 4th power is 16, x to the 4th plus 4. If I cube this, I get 8x and a minus 5y plus 6. And again, square this, you get 4x squared. Here we get a plus 25y squared. And then when I cube this, 2x stays the same, then minus 125y to the 3rd plus 5 to the 4th would be 625, y to the 4th. And I don't need to put the 1 there. Let's finish this up. 16x to the 4th minus, right? Because there's going to be a minus there. So that should be a minus 32 times 5 is going to be 160. And that should have been a cube there. So it's going to be x cubed y. And then 6 times 25 is 150 times 4 is 600. So it'd be a plus 600 x squared y squared. 4 times negative 125 is going to be negative 500 times 2 is going to be negative 1000 x y cubed. And finally, plus 625 y to the 4th. So those are a couple of the big things to make sure you're familiar with from the 5th test. Let me reiterate a few highlights from some previous tests. And let's go down to problem number 11 from exam 2 for that. So here's exam 2. I thought it was exam 2. Oh, here we go. Actually, it's exam 1. So one of the things I could ask you is this a function? And the answer is yes, because it passes the vertical line test. Is it an even function? No, because it's not symmetric with respect to the y-axis. How about, is it a one-to-one function? Again, the answer is no, because it fails the horizontal line test. So a couple quick questions there. Now, as far as a lot of the rest of the stuff, this is boilerplate stuff that you should know for moving on. Domain and range. Domain is just where this function lives in terms of the x's. So it starts out here. Starts out here at negative 2.97. Let me put a solid dot there. And it goes to here, positive 2.97. Let me put a hollow dot there. If you look at the answer, I'm including the negative 2.97, but not including the positive 2.97. That's because there's a hollow dot here at that endpoint. Local minimums, I accepted people who gave me an answer of -5, even though I don't really consider that a local minimum. In fact, it's not. It's not even on the graph, but I accepted that answer. The local minimum really should be just this point right here, -2. And over here, we had a local maximum at 2. I also accepted 5. 5, you know, you can see people arguing that 5 is a local maximum. So I was okay with that. Increasing and decreasing. So the function's increasing starting here over to here. Now that's going to mean increasing along the x-axis. So let's see, it's going to start around here. And it's increasing all the way to the right until we get to this point. right here. So those x coordinates, that's going to be from negative 2.016 to 2.016. Decreasing, well, that's going to be kind of everything else then, right? So decreasing is going to be here, starting here to the end, hollow dot. In fact, decreasing and increasing always get hollow dots, at least in my humble opinion. And that's pretty much it. This is kind of a nice little bonus question here. Where is it greater than 0? That's just asking you, well, at what point is the graph greater than 0? So, well, from negative 2.97 to negative 2.6, and then from 0 to about 2.6. So in that interval, the graph lies above the x-axis. So those kind of analytical skills will serve you well moving forward. And it's something that I definitely want you to be comfortable with for your final exam. Expect something like that. Problem 13, exam 2. Didn't go over so well. Some of the same kind of stuff. So to find the x-intercept, you can set the numerator equal to 0. So 3x minus 12 equals 0 gives you x equal negative 4. If you want to find the y-intercepts, you set x equal to 0. Setting x equal to 0 is just a calculation. You get negative 6. The horizontal asymptotes. Remember, there was 3 cases. If the numerator and denominator have the same degree, then it's going to be the ratio of the leading coefficients. If the numerator has a degree that's less than the degree of the denominator, then y equals 0 is your horizontal asymptote. Vertical asymptotes are going to occur where the denominator is 0. And finding where the denominator is 0 helps you out in another way too, because these points, x equal 2, x equal negative 1, where the denominator is 0, not only are there vertical asymptotes, but they're places that the function doesn't exist. You can't plug in those values into your function. So we're going to want to exclude those points for the domain. So it can't be negative 1. It can't be 2. So it's everything but those values. That's what I have here. The range, you have to look at the graph, find that. I would assume you use Desmos to try and look at that. And the range is everything. Remember, there's a bonus point for people who use R correctly. And last but not least, one little thing here about graphs. So reminding you that we translated some graphs. Let's look at some basic shifting around first. So that's supposed to be kind of part of a parabola. If I were to look at h of x is x plus 2 minus 3, that's going to shift my graph left 2 and down 3. Remember, your horizontal shift takes place opposite of what the sign seems to indicate. Instead of 2 to the right, it's shifting 2 to the left and then down 3. So this point at 2, 2 would shift to the left 2 and down 3. So you have a graph look kind of like that. This point would be at 0, negative 1. How about some of these other things? Well, f of x is, or it should be g of x is f of negative x. That's going to cause a reflection. Want to pause video? Can you remember how that goes? All right. Bonus points to those of you who said it's going to reflect it around the y-axis. So this point would here be at negative 2 and 2. All right, I meant to have that be touching the origin there. What else? You can stretch this graph. If you multiply by 2, that's going to be a vertical stretch. So this point would still be at 2, except the height would be at 4. That would be your R of X. What about this one? Well, that's going to shrink things. So this point would then be at 2 and 1. So a lot of things we can do with our graphs, but hey, those are some good tips moving forward. I wouldn't be surprised to see one like this here on the exam as well, especially something like that, where I'm asking you to basically evaluate function using the given graphs. So good luck.